Hi, welcome to Real Learning Center. We are on the sixth video of our laws of motion. So, Newton's laws of motion. Sixth video is about the collision, and you can see the collision of the two cars, the accident, which we call. Okay, it's collision. So, what do we study in collision in physics? We'll see that today. Okay, so today we have basically till now covered causes of motion and Newton's three laws, understood momentum, and finally we are today on to collision, where we are going to use some of the concepts that we have learned in the Newton's laws. Okay, so what are these? We'll see. Okay, so now where do we see collision? Where are the collisions that we generally see? Is it something that we see only in physics, or it is seen in everyday life? So let's see. You can see in the cricket, a batsman actually hits the ball with his bat, and that is a collision of bat and ball. That they hit each other in a sense. Okay, so that's collision. It's a normal day-to-day thing that we see. And in the very micro world, you can see here it's a very interesting nuclear phenomena that I have put here. Okay, you take a neutron and collide that into an uranium atom, nucleus. It splits into two, causing nuclear fission, or we call nuclear bomb. Okay, so that is one more place where we collide. Collision happens, and this is at a very micro scale. Now, in even very huge macro scale, you can see collisions. Galaxies colliding. Two huge galaxies collide. Okay, and what will happen when they collide? So there is a collision there. And you can see, even coming back to normal games, you can see that the ball is actually bowling ball. It's colliding. Okay, so in all these collisions and many more places where day-to-day collision happens, okay, the laws that govern these collisions are all same laws, Newton's laws. And what happens in a very minute level within the atom is same as what happens on a very huge level of galaxies. You can use simple equations to calculate things. So today we'll understand what are the laws which govern these collisions. What are these collisions? How do we understand and study them? Okay, let's start with just a quick recap of the Newton's laws. We said that the first law was a lazy law, where things either are at rest or at uniform motion unless disturbed by an external force. And if that external force disturbs something, how fast that goes, what is the acceleration that we can compute, that is the second law. And the acceleration is actually directly proportional to the force and inversely proportional to the mass. Which means if smaller mass goes fast and bigger mass accelerates slowly. Okay. So, and the third law, we said that whichever pushes also gets pushed. That is the third law. So every action has got a equal and opposite action. So we have understood all these three laws. Now we are going to basically see how do we apply these laws in our collision. Yeah. So let's take two types of collision. We have two different kinds of collision. So what are they? If you watch these collisions, so you will know what are those two types. Okay, on the top what I have is you have two glass marbles, playing marbles, or you can say glass spheres, what we call, two of them, solid ones. And in the bottom you see basically it is nothing but the clay lumps. Okay, you have two different clay lumps. Clay, it may be clay dough or a clay. Now, so what we are going to see is two of them are there. Okay, so one is big, another is small. Okay, so when it hits, what will happen? You just keep watching. Okay, when it goes and hits that one, and both of them will move. Only thing is their speeds have changed. Okay, this is one kind of collision. And there is another kind of collision where you can see that it will start moving towards that, and it will hit and get attached to that, and they may move together. Okay, the clay gets stuck with the other clay, and it becomes one mass, and they move together. So that is the second kind of collision. In the first kind of collision, they did not get attached. They came in contact, but they separated and they moved. That is the first kind of collision. So we call that first kind of collision as elastic collision, and the second kind of collision as inelastic collision. So why do we call it like that? The reason we call it like that is, whenever what is elasticity? Elasticity we have learned in our day-to-day life. You take an elastic, or you take a rubber band and pull it, and you leave it, it goes back. Or you take a spring and compress it, you leave it, it goes back. Take a rubber ball and press it, you leave it, it goes back. So to going back to the original shape after giving a certain force on it and change its shape, that property is called elasticity. Okay, so now this glass ball is really very, very elastic. Okay, in the sense that if you actually hit it with something else, it actually changes this shape very minutely, and that comes back again to the original shape. So that is called basically elasticity. So in this collision, that elasticity works in the sense the moment it hits it, it temporarily changes the shape a little bit, and then restores back to the original shape. That is why it is called elastic collision. Whereas the second one is inelastic. The clay, basically, when you change the shape, it doesn't come back to the original shape. It goes and hits and gets attached to that. It doesn't come back to the original shape. So then they both travel together. That is an inelastic collision. So these are the two kinds of collision we have seen. Now let us see how do we understand these collisions in terms of Newton's laws. So let's start with inelastic collision. That is supposed to be slightly easier to understand. Okay, inelastic collision and Newton's laws. What does it say? So now we will get into basically understanding the details of each one of those masses. So the first one is a clay, which is, let us say, 2 kg of clay, and second one is M2, is 1 kg of clay. And we saw that when you press it, when you start it, the first one will keep on moving with a velocity of, let us say, assume that 3 meters per second. Second one is not moving; it is stationary initially. It is basically 0. So that's what I call V2. Okay, V1 is 3 meters per second and V2 is 0. Now after seeing that, now what we will do, so the arrow that you see is velocity arrow. That means velocity is in that direction, okay, of the first one. Now what I am going to do is, I am going to consider this whole thing as one single system. Okay, this is my one single system. What is the meaning of system? System means multiple bodies together is one system. Okay, so the Newton's laws are not only applicable to individual objects, they are also applicable to the whole system of bodies, the multiple bodies. So this is a multiple bodies system. 2 bodies are there. Okay, bodies, I mean objects. Okay, this is a 2 object system. Now in such a system, if you actually run this, what will happen? We will see. Okay, so how do we analyze this? In this whole system, is there any force that is being acted upon on this system? Is somebody pushing the whole system from somewhere? Is there a force? That question we are going to ask. Okay, so now we know that according to Newton's second law, force changes momentum. If there is a force, it changes momentum. If there is no force, it doesn't change momentum. So we have to first understand what is the momentum of this system, the whole system. The momentum of the whole system is momentum of the individuals added. Okay, this one is basically mass 2 kg into its velocity, which is 3 meters, 2 into 3. Okay, and momentum of the other one is 1 into 0. So if you add that, then you will get finally 6 kilograms meter per second. That is the total momentum of the system. Okay, now this momentum, okay, is what we call initial momentum before collision. This is our momentum, and we know that are there any forces like this acting on that? If I put these arrows, there will be forces. So I will not put the arrows. So there are no forces. No forces acting on this system. So when no forces are acting on the system, we can clearly say that the momentum of the whole system cannot change, because second law, Newton's second law, says that rate of change of momentum is proportional to the force. So force is 0, rate of change of momentum is 0. That means that you are going to have no change in the momentum. Okay. Now if there is no change in the momentum, what will happen? We will see. Okay, we see that momentum actually changes of the mass. It changes its velocity after hitting, but total momentum will remain same. So if I actually look at how the hitting happens, it goes and hits, gets stuck, and the whole system will move. Okay, when the whole system moves, the m1 plus m2 moves with a velocity, let us say v3, some other velocity, it moves. It is not the same as original first velocity. Okay, so we want to calculate what is the final velocity. After they are stuck together, what velocity it moves. So how do we calculate that? So that is why we take the help of Newton's second law, and where momentum cannot change without force. Okay. So now what we will do is we will calculate the momentum after collision. Momentum calculation is always about multiplying velocity and mass. So velocity is v3 and mass is m1 plus m2. So we both, if you add those, because those masses are clinging together, so it is basically addition of those two masses. That would be basically equal to 2 v3 into 2 plus 1, which is 3 v3. And we know very well that momentum cannot change, means earlier momentum was 6 and now also momentum has to be 6. Now since momentum has to be 6, we will equate that 6 to 3v3. And from there we can easily calculate what is the value of v3 from basic simple algebra. 3 v3 is 6, means 1 v3 is 2 meters per second. Okay, so that is what we have calculated. So we were able to use Newton's second law, conservation of momentum, what we call momentum cannot change. From that we calculated what should be the combined velocity, and that is how inelastic collisions are dealt with. Now this not changing the momentum does not change. So we use a technical term to use that and to say it. So we say it as law of conservation of momentum, means momentum does not change. Okay, if there is no force, momentum does not change. To say that, we will say law of conservation of momentum. So inelastic collision, we have to use law of conservation of momentum, and we will come to know what is the combined velocity. Let us now see what happens with the elastic collision. Elastic collision has some 3 different cases I have taken. Okay, the first case being that both the glass marbles are of equal size. In the second case, the first marble is bigger than the second, and in the third case, the first marble is smaller than. I will hit using a smaller marble. In the first one, I will take a bigger same size marble and hit. The second one, I take a bigger marble and hit a smaller marble. So what will happen? You can guess. If I hit with a same size marble, what will happen? Think about it. Okay. So when you think about it, let me see whether we get the same thing. Okay, our experience. When you are playing the marbles, you would have got this experience. Okay, so now when you hit it with the same size, it so happens, by experience, by experiment you can see, it so happens that the second marble went away and the first row of marbles stayed there. What does it mean? The second marble got a velocity and went away. The first marble velocity became 0. Means momentum became all its momentum, mass into velocity, went into the second marble. It poured all the money into the pocket of the other guy and it went away. So that is basically case A. Case B, think about what will happen. In case B, the bigger one is hitting the smaller one. Let us see what will happen. So it goes, and when it hits, the first one actually slowed down, but second one also went away. Okay, that smaller one went with very high speed, high acceleration. Okay, and what will happen to the third case? Let's look at the third case. Imagine what will happen. Predict it, and then see whether you are right. Okay, let's see. Wow, it's actually, as you can see, that it comes back, the smaller one, and the other one moves in the other direction. Second one moves in the other direction. This is basically the case 3. Now, how do we now use our understanding? This is our experience. Okay, this is what we have seen. Our experience tells us. Now, how do we compute? Now, we know that it comes back. We know it goes. What is the velocity? How can we complete? What is the velocity of the second ball after collision? What is the velocity of the first ball after collision? How do we compute all this? So, let us see whether we can apply any laws for this to compute. Well, let's take a case A. Okay. In case A, what we did, we had two equal sized balls, equal mass also, 2 kg, 2 kg. Now, the first one is moving at 3 meters per second, second one is moving at standing, and it is 0. So, I will use some notation here, you can watch. I will call this as m1 and m2, and velocities I will call it as v1 before, v1b, 3 meters per second. Okay. V1 means velocity of the first mass before the collision, V1b. Okay, understand that notation. Second one is V2b, velocity of the second one before the collision, 0. Now we will have the collision. So once you have the collision, what happens to the velocity? So we will call them with different names now. We call it as V1a, means velocity of the first ball after collision. A is after, becomes 0. V2a, velocity of the second ball after collision, is 3 meters per second. It went out with the same velocity as the first one had earlier. Okay. So this is the observation. This is the observation when you really do it physically. You can see this observation. Now let us see whether what law it works. Now what is the law that governs this? We can clearly see that momentum is conserved here. Law of conservation of momentum is applied here too. Because you can very nicely see that initial momentum, the first momentum is basically 3 into 2, 6. Okay, and even after the collision, the momentum has become 3 into 2, 6 only, because the other one has stopped. So law of conservation of momentum has worked. Okay, now the question I am going to ask myself is it this easy? Okay, what happens when I use a bigger ball and a smaller ball? How do I calculate? I will get some equation, but it will not be sufficient to calculate. How much it will reduce? How do we know? Okay, so the question is this rule is this sufficient here? Is this the only rule? That is the question that comes. If this is the only rule, then I would have said, for example, that the V1 after is 1.5, okay, and V2 after is also 1.5. In which case 1.5 into 2 plus 1.5 into 2, again you will get basically 6. So I could have got conservation of momentum worked even then. Okay, so what I mean to say is that when the ball went and hit that, instead of giving all its momentum to the other ball, why did it not give half the momentum? Why did it give all the money from its pocket to the other guy? Why couldn't it give half, so that it can also go at half the speed and the second ball also goes at half the speed? Why did it not happen in the nature like that? Question basically is, why doesn't the nature behave that way? That is the question. So in order to understand the elastic collision, okay, we need a little more understanding, slightly beyond the Newton's laws. Some more concepts need to be understood. So the most important concept that we need to understand there is something called as law of conservation of energy. Okay, there is a new term called energy. So that law of conservation of energy, it is basically energy because of the motion, kinetic energy we call. So we need to use that to be able to calculate exactly the velocities in the case of elastic collision. So elastic collision follows both law of conservation of momentum and energy. Momentum also happens. And inelastic collision only follows law of conservation of momentum, because energy is lost in an inelastic collision. In the sense, when it collides, what happens is that it changes the shape. When it changes the shape, the energy is lost. That's what we say. Some work is done. So when we go into the details of what is work, what is energy, what is potential energy, during that time, what is kinetic energy, we will actually come back and deal with how to solve elastic collision equations. So for now, understand that inelastic collision is something that can be easily solved using conservation of momentum. And elastic collision, in simple cases you can solve, but in complex cases you need conservation of energy. Okay, so that will lead us to the next chapter after this, which is work and energy. So we have now done what causes motion, and we have also looked at Newton's laws. What is momentum, you understood. What is conservation of momentum, you understood. We also came to know about two different kinds of collisions, elastic and inelastic collisions, and how to deal with them. So come back, let's come with new videos where we will discuss more and more about physics. Happy watching. Thank you.